JJ Math.
So sometimes with a grade 12 stats question, they connect it with a scatter plot. So remember, we do grade 12 stats when there's an X and a Y value that's connected together. So in this example on screen, they took a few students and they connected their math marks with their science marks. And then they check, is it true that if someone does better in math, they also do better in physics? And yes, according to this, that seems to be true. So depending on the questions, you would sometimes have to get the line of regression, and other times you'll have to sketch the line of regression. That's what we're going to focus on. So in the bottom block, to draw the least squares regression line, we first going to find the average of x, or the mean of x and the mean of y. That is going to give us a dot there somewhere in the middle of all the data. Then I'm either going to make a dot on my y-intercept, okay, or I'm going to choose the biggest value of x that fits on the graph. So I'm going to choose an 80 or a 90, and then sub it into the x in my formula, this x up there, and I'm going to find a different coordinate. So let's say I sub in 80 and it gives me a value of 85. I'm going to sub it in there, and then I'm just going to connect the dots. And that would be my least squares regression line. So how do I find the mean of x and the mean of y? You're going to type in the data just like normal. So the left block, you are going to do, you're going to press AC, and then instead of doing shift 1 and then choosing a regression, you're going to say shift 1 and you're going to choose option 4, which says variation. And in that menu, you'll see an X with a little line on it and a Y with a little line on it. So then you just choose those two, and that would form a coordinate. Let's do a few examples so you can see exactly how it works. And now let's actually do this question and see how accurate my little rough sketch was. A mathematics teacher was curious to establish if her learners' mathematics marks influenced their physics marks. In the table below, the mathematics and physical science marks of 15 learners in a class are given. Determine the equation of the least squares regression line. Okay, by now you guys know how to do that, so let's type it in and see what A and B would be. So according to my calculator, y equals 9.5 and then plus 0.9x. So there's my A and B, and that's my least squares regression line. Now, draw the least squares regression line on the scatter plot for 2 marks. So they're going to give you a mark for your mean of x, mean of y mark, and then just if your line has the correct shape. So let's first find those coordinates. So remember, you now have everything on your calculator, so now you can press AC, shift 1, choose option 4 for variance, and then get the x with the line on and the y with the line on. So according to my calculator, the mean of x in this case is 45.07, and the mean of y is 50.47. If I look at the graph and I need to plot that point, so I'm going to go 45 units to the right and 50 units up. So it would be around there where I will make my mark. Okay, so now I have an option. I can either take my least squares regression equation and sub in 80, or I can see what the A value was and make a dot there. In this case, I'm going to do that. So I can see A is 9.5. So when X is 0, Y is 9.5. And then I just take my ruler and I connect those two dots. And that is the least squares regression line. So with this, you can just write in that coordinate for your teacher. They will really appreciate it. So 0.7 and then 50.47. And then there I can just write that was 9.5. Okay, great. For that, I would get 2 marks. Predict the physical science mark of a learner who achieved 69% for mathematics. Okay, so to be accurate, you are going to take your equation and just sub in 69 in the place of x. My calculator tells me the answer is 71.6%, because this is all about marks. Write down the correlation coefficient between the mathematics and the physical science marks. So then you can just go on your calculator and get the R value. And in this case, I can see that R is equal to 0.95. Comment on the strength of the correlation. That is above 0.8, but it's not 1 yet. So for question 5, my answer would be strong positive correlation. Okay, perfect. 1.6. What trend did the teacher observe between the two results? Okay, so there's a very strong correlation, but I now need to say it in language pertaining to math marks and science marks. So my answer is going to be, when someone does well in maths, they tend to also do well in physics. And for that, I would get my marks, because that's the trend that we notice. Question 2. So the table below represents the distance in meters required by a car to apply the brakes and reach a standstill when it is traveling at a given speed. So in this case, my x values are all speeds in kilometers per hour, and the y-axis is braking distance in meters. Now, if they ask me to draw the scatter plot, I just need to go and make those 7 dots. So let me just do the first 2, and then I'll just complete the picture. So it says, when I go 20 to the right, I must go 6 up. So I'm going to make a dot there somewhere. When I go 40 to the right, I'm going to go 16 up. So it would be there. how easy it is to do a scatter plot. So just make sure you don't mix up the dots, but just make the dots, and for that you will get 2 marks. Explain whether a linear, quadratic, or exponential curve would be a line of best fit. Okay, this looks pretty straight to me. I can take a ruler and draw it through almost all the dots. So I think if this experiment goes further to about 300 kilometers per hour, then it will definitely be an exponential curve. But for now, this is just a straight line. Question 3, determine the equation of the regression line. So y is equal to a plus bx. Just going to type in everything on my calculator, and then I see that a is minus 17.14, and then b is plus 0.86x. Draw the regression line on the scatter plot. So once again, I'm going to look for the mean of x and the mean of y, and then I'm going to plot that coordinate. So according to my calculator, the mean coordinate would be 80 and 51.43. So if I do that on my graph, I'm just going to go 80 to the right and then 50.13. So it's just going to be above that dot there. Okay, so now I said previously that we can just plot our a value. In this case, the a value is minus 17. That's not accurate because we can't go minus 17 meters back. So in this case, I'm going to just choose a dot to the right. So let's say 130 or kilometers per hour. I'm going to sub that into the equation, and then that's going to give me my second dot that I'm going to make in order to connect them. Calculator tells me this is 94.66, and now I can just go and make a dot. So I'm going to go 130 to the right, and then just 96. So it's just going to be there. So now I can just take the ruler and connect those 2 dots to get the line of regression. And there we go. I plotted the line. Use the regression line to estimate the braking distance at a speed of 150 kilometers per hour. Is this estimate based on interpolation or extrapolation? Okay, so remember we said extrapolation is if it's outside the given data. Now my highest value that I know is 140 kilometers per hour. So this would be based on extrapolation. Now if I use my line, I can see 150 would be about there. Let's say 112 meters to stop. So because they say use your regression line, you can either use the sketch or you can sub it in the calculator to get the value. But the answer for question 5 would then be 112 meters if I use the graph, but this would be extrapolation, so it's not very reliable. Question 6, the same question, but now on 130 kilometers per hour. Now, luckily, we already worked this out, and we saw that was 94.66, and that was inside the data, so that was interpolation. That's it. This is really all you need to know for grade 12 stats. I hope it makes sense. Go and get these marks.
If this video helped you, please like and subscribe.
JJ Math.